Hi, Vince Math. It must be Maths by Amiya. Welcome again to the world of Maths by Amiya. The best questions before examination or the most tentative question is going on. If you have not joined the Facebook event, you must join. Or questions we are going to share on Facebook event, we try to share everywhere. But I would say must join the Facebook event. Link is given in the description. So this is question number third of the most tentative questions before your examination. Question is in front of you. I would say please pause the video and try to solve the question. I hope you have paused the video and tried to solve this question. Now check this solution. This one is termed as the reverse Euler. What do you mean by the reverse Euler? When a number divided by another number and the power is the cyclicity of the numbers, or you can say in the terms of prime, if A and the other primes are the co-prime to each other, here also the co-prime, and the power is p minus 1 or its multiple, then the remainder in each case is 1. I hope it is okay. Quite an easy question. So in case of 101, we know it's a prime number. The cyclicity of any prime number is less than 1, that is 3 raised to the power 100. The remainder should be always 1. You have a prime number, power is p minus 1 or its multiple, both are the co-prime, remainder should be 1. That's the Euler or cyclicity. What is reverse Euler? If our power is just smaller than the our cyclicity, so we say we have 3 raised to power 98 divided by 101, what would be the remainder? So I say it's quite tough to solve this question. 3 raised to power 91 into 3 is square. If we divide, this will give the same number. So this one is termed as the reverse Euler. We first work on the Euler, then change number into some product as equal to Euler, then we solve the question. So say this remainder is x, assume into 9 would be remainder 1. So the required remainder into 3 square is 9 would be the remainder when divided by 1 is actually equal to 101 into another number plus 1. So we wrote nothing but Chinese remainder theorem. We know 3 raised to the power 100 divided by 101 is 1. So this is a number when divided by 101 is 1. That is 101 is a divisor into quotient plus 1 because remainder is 1 as per the Euler. So 398 into 9 divided by 101 should be 1, or in this form of numbers 398 is the required remainder. So we need to work on this value. First check with the option. If we take x is equal to option number A, 9, 9 9 are 81. When the 81 divided by 101, remainder is not 1. So this one is not the answer. 45 into 9 is the 405. Yes, 405 divided by 101, remainder is 1. So answer of this question is this one. Or you can say the x is actually equal to 101 into some value plus 1 divided by 9. So x is an integer. So here we know 101 divided by 9 remainder is 2 into something plus 1 should be divisible by 9. So this something must be 4. So we know this one is 404 plus 1 divided by 9 is equal to 405. 9 is 45. So our value of x is, which one is the required remainder, is 45. I hope this one is one of the best method to solve this type of question where the power is just below the your cyclicity or the Euler. Then we termed it as a reverse Euler. If you have option, check with the option. If you do not have the option, write the Chinese remainder theorem, work on the values and solve the question. If you do not have options, or they say find the product of the digits, find the first digit of the numbers or the second digit or so on. So this method is termed as reverse Euler. I hope you learned the method. Just solve a question. 2 raised to power 94 divided by 97. What would be the remainder? I would say please rewatch the video, understand the concept. We work on the cyclicity, then the reverse cyclicity into something extra to make the numbers as per our cyclicity or the Euler. Then we work on the Chinese remainder theorem, some hit and trial, and get the answer. Now solve this question and post your answer in the comment box. 2 raised to power 94 divided by 97, what would be the remainder? So this one is the learning of today's solve the best question before examination. I hope you are giving your best. I'm trying to give my best. Let's crack the examination. Myself, Amiya. God bless you. Happy learning and bye bye.